Have you observed this one? What is this one? Yes, it is a ocean or sea. You can observe here the waves in a sea. How the waves generally occurred in a waves, you can observe it. It has the different shapes. You can see here. This one, the wave is similar and continuous the wave. Okay, so naturally it is occurring. So dear students, in this class we are going to learn the wave winding. Wave winding. Okay, so what is a wave winding? Where we are going to use this wave winding? How to develop wave winding in single layer, in double layer. We will take one practical example. So we will develop one full winding diagram. Let us recollect what we have seen previously, just 1 or 2 minutes regarding to our electrical winding. If you observe here, this is the one armatures used in our electrical field at different applications. Okay, so in DC machines we are going to use these armatures at different applications oriented. So that may be in ceiling fan. If you are observed, this armature can be used in trains where it has a fans, and different applications we may across this type of the armatures. The armature winding may be connected in two types. One is the lap winding, another is the wave winding. These two types of the windings generally across in our electrical field to run a DC machine. Lap winding, regarding to the lap winding, we already have seen previous classes a different type of the lap windings, single layer, double layer already we developed. Now in this session we are going to cover the wave winding. Okay, so let us see that also. Recollect what we have discussed in previous classes. These electrical windings are classified into the two types. One is the DC winding, another is the AC winding. In DC winding and AC winding, so we used then coils, the open coils and closed coils, but in case of DC machines we generally used the closed coil. Okay, so that is in first figure. If you observe the top here, you can observe this is a lap winding. So what is the lap? We have seen Hanuman tail, just like it is going and this type of the winding. Okay, so now whereas this winding is a wave winding, you can observe here. So how it is developed, and coming to the wave winding, same armature here, but the winding coils, it is starting in under one pole of one coil side. If you are seeing, this is a one coil, so this is placed here one slot. It will connect it to the another side in the adjacent pole, you can see here. Now in this case, the coil another, it is connected to the another coil of another pole. So it is, you can see here, it is connected to another pole. Okay, so whereas in this one, so this is connected and it's coming to the back once again, but there is no back here, it is going to the other side. Okay, just like it is appear as a wave. You can see connections in the commutator where it is connected to the one segment, and this coil is connected, and back pitch it is going to the ear, and it is connected to the another coil ear and is connected to, so it going to the another ear. Okay, so this is a similar wave. That means this wave connected here, just like a wave. Okay, this is a wave winding. So what is the definition of the wave winding? Let us see. You can observe here, the finishing end of the one armature coil is connected to the starting end of the other armature coil commutator segment at some distance apart, not subsequent commutator segment. Here you can observe, what is that one? Let us assume this is the one commutator segment here. This is the one commutator segment. For example, we started here. Okay, so here this coil is connected, this red color coil is connected under influence of north pole here, and the coil side another is connected the under influence of south pole here. You can see here, this is the one coil, and it is connected to the one commutator segment here distance. Okay, now this commutator segment and this commutator segment, you can see here, is a apart distance here, and this is connected, another coil is connected here under influence of north pole of here, and is connected to the another side south pole of other side, and is connected to the another commutator segment. Okay, so this is a wave winding. The commutator segments apart, the finishing end of the one armature coil is connected to the starting end of the other armature coil commutator segment at some distance, not here. Okay, so this is one example. Okay, now you can see here the armature generally observed. This type of the winding is a wave winding. Get the good idea. Let us assume here this is a one north pole, okay, and this is a south pole, north pole and south pole, 4-pole machine. It has the 12 conductor slots. Okay, it's a conductors. Now the first conductor, you can see here, this is connected in place in the first conductor of the first coil, and is connected to the, this is known as the back pitch, is connected in the fourth conductor. So we can say this is a distance of YB, back pitch. Now this coil is connected to the other coil where at a distance of one pole pitch, you can see here. So here he connected the ear once again. So then we can say this is known as the front pitch, Y, F. Okay, so this is the back pitch, this is the front pitch. Now we can say, so this and this, we can say this is a YR, resultant pitch, the distance between the two, starting up the two coils, resultant pitch. Now this is connected, this another, it is connected back pitch, connected here, and is connected the another south pole, and is connected to the next another here, it is coming to this place. Okay, it is connected to the under pole second coil, it is connected to second coil, and the second coil once again is connected to the here at a back pitch of here, and this is the second coil second end. This is connected to the eighth, so you can see is the another, the pole pitch is connected here. So such a that it is completed the simple wave winding, dear students. So for this purpose, so as usual, so we required one is the winding table. So first prepare the winding table. Based on the winding table, so you connect YB and YF, so end connections. Okay, so here so you have to observe one thing. In wave winding, generally it has only two parallel paths. A is equal to 2 only. Any type of the machine which has winding of wave winding, it has only two parallel paths. Whereas in lap winding, so the number of parallel paths is equal to the number of poles. Here the number of poles may be 4 pole or 8 pole or 2 pole, any type of the poles, but number of parallel paths are only 2. Okay, that's why so this type of the winding generally used in high voltage and low current. Okay, generally it is used where we require the high voltage and with low current preferred, then we can use this type of the wave winding. Okay, so only it has two parallel paths are provided between the one positive and negative brushes. Okay, so these are the some simple basics regarding to the wave winding, dear students. Okay, please remember that. So here this is the first coil, so you can see, so these two, this one is known as the YB. If you observe in wave winding, the YB is equal to YF. Sometimes the back pitch and front pitch always odd or equal or difference by 2. Generally it preferred the back pitch and front pitch so equal to the equal values and odd numbers. Okay, now you can see the this distance from the this one coil another coil, we can say this is a front pitch. Okay, so here commutator segment, here this is a 1 and you connect 2, 3, 4, 5, 6 at a pole pitch and it is connected here. Okay, is a continuous under influence of one pole pitch. Let us develop one practical example of wave winding. So dear students, you can observe this is our one armature generally used in our electrical field which has a wave winding. Okay, so this wave winding means, so as usual this is known as a shaft, this is known as the commutator, and these are the winding, copper winding, these are the armature segments. Okay, now this is the slots. Okay, so slots you can see the winding is placed in between the slots with the insulating paper. You can see this is the one slot, this is another slot, this is another slot, and this is another slot, and here another slot. So it has the all slots connected around the armature. Now the coils may be number of conductors. So single, it may be simple one conductor for a coil, and sometimes we can use, so here So a number of conductors for a coil. Singleton is a multi-ton. Okay. Here it is a number of tons, number of conductors here, number of conductors in one coil connected for the development of the more voltages. Okay. So here remember, so this one coil side is placed under the influence of north pole, and that should be placed, another coil side should be placed the opposite south pole. Okay. So such a way that we are going to develop. So let us take one simple wave winding. So how we are going to connect this commutator, placing up the brushes, how we are going to connect our winding to the commutator segments, and our winding how we are going to connect with the wave winding given with the given data. Let us develop one thing. And dear students, here one problem is given, practical problem. Develop a simple wave winding for a DC machine having 34 armature conductors and 4-pole machine. That means here the number of poles is given 4 pole, number of conductors is given 34. Simple wave winding. Okay, so total conductors are 34 and number of poles are 4. So simple winding. So let us develop that. So total conductors is given, total poles is given. We can develop the winding diagram based on given data after knowing back pitch and front pitch. So this is a single layer winding. So we will do the, already we very familiar about the lap winding. What is the single layer lap winding? So in this class we can develop somewhat a difficult problem, that is we can develop the double layer winding. Okay, so let us do that one. So same number of conductors. Here develop a double layer wave winding diagram of wave winding for a DC machine having the 17 armature slots and 4 poles is given. Here 17 armature slots. So S is equal, slots is equal to 17, and 4 poles machine is given, poles is given. So it's a double layer. That means each the armature slot consists of 2 coils, 2 conductors. This is the one conductor, this is another conductor. That means so total number of conductors may be 2 into 17. That means so total 34 conductors. Okay, so based on Z is equal 34 conductors and poles is equal to 4-pole machine. So we are going to develop the simple or a double layer wave winding. Okay, so single layer and double layer is a similar, dear students, same procedure, but so here what is the double layer? So we are going to top conductor is indicated by the solid one, and bottom conductor, this one, so indicated with a dotted line. Okay, so the similar way. So here also the top one we are observing, we can see, and bottom one we cannot see. That's why we can go in drawing. We can see we can place with dotted lines. Okay, as already you know it. Double layer wave winding. Okay, so here the what is the problem is given. The number of poles is 4, total number of conductors 34, wave winding, the progressive winding. Instead of retrogressive, so we are developing the progressive winding. These are the some constraints. To develop any winding, we have to follow the few steps. Okay, easy to understand, easy to draw the diagram. So what are those steps? Let us first one, the simple calculations for what is the pole pitch, what is the back pitch, what is the front pitch. So based on some formulas we discussed in previously. So first find what is the back pitch and front pitch. Now after knowing this back pitch and front pitch and pole pitch and average pitch, resultant pitch, everything, then you prepare the one simple the winding table. So winding table is the basics to develop the winding diagram. After developing the, so after preparation of our winding table, then proceed for the winding diagram. Develop winding diagram with the help of winding table and connect the end connections to the commutator segments and place the brush positions appropriately based on current directions in armature conductors. Whether is the upward, both are similar in a coil, then you place the one brush position. So we assumed that the current in the coil same directions coming towards the commutator segments, we place that is a positive brush position, and the current is away from the commutator segments in a coil, we are represented as a negative brush position. Okay, similar to the previous lap winding. Now you can see, let us do after that, rather last step is the, if required, develop a ring diagram. Okay, these are the 4 simple steps, dear students. First, prepare the simple calculations, then prepare the table, prepare the winding diagram, and finally finish with the ring diagram. Okay, similar to the previous lap winding. And let us do one by one in simple steps. Now, for development of the wave winding, so first step is the simple calculations for the number of poles, back pitch and front pitch values. So what are the salient points regarding in wave winding? So first one is the back pitch and front pitch must be odd and equal to one pole pitch. So always odd number, that may be 9, 7, 11, 13, whatever the values data is given, and it may be equal values, or sometimes it is differ by the, so YB minus YF equal to the 2 or multiple of 2, or sometimes YB is equal to YF. That is the one point in wave winding. Next is the resultant pitch. So what is the resultant pitch? The starting distance between the two starting coils. So here YB plus YF is the part distance is more. Now the commutator pitch. So commutator pitch is equal to, here we can write it, so a simple way. So instead of here, the commutator YC is equal to, we can write it, number of segments, number of commutator segments. Okay, so plus or minus 1 total divided by P. So that means if you know the commutator segments is in the given 17 commutator segments, plus or minus 1 by P. So that means here, so what is the value? 17, the total number of commutator segments 17. Okay, so 17 plus or minus 1 divided by P. So this is the commutator segments. Okay, P is equal 4 pole machine. So here you are going to get it. So that is a 18 or 16 by 4. Okay, that is the one formula. Next, and average pitch. In this case, average pitch is equal to total number of conductors. So you can see YA is equal to, we can say Z plus 2 divided by number of poles. So what is the Z here? Z is equal to 2 into 17 slots. Okay, so that is equal to 34 plus 2 divided by 4. We are going to get the average pitch. What is the average pitch here? So you can see the 34 plus 2, that may be 34 plus or minus. We can say, we can take the plus or minus, we can say plus or minus. So that is a 34 plus 2, that is equal 36 by 4. So 4 ones are 4 nines are. So it may be 9, or sometimes you can say the minus value 34 minus, so 32 by 4, this is 8. That means here 8 or 9 as a average pitch, but so we preferred only odd number, we will take, so 9 as our average pitch. Okay, 9 as our average pitch. Sometimes we can take this average pitch YA is equal to YB is equal to YF also. Okay, so these are some techniques, dear students, remember. Now, after knowing the armature, so the average pitch, then you find it. So that previous value, that is a YB plus YF by 2 is as usual. So after knowing the average pitch, you can easily find that what is the back pitch, what is the front pitch. These are some salient points you have to remember before proceeding into our wave winding. Okay, so let us develop one. So what is the question is given? Here question is the pole number of poles is 4 is given, total number of conductors is the 34, and wave winding, not lap winding here. So this is a wave winding, this is our question, and it is a progressive winding. So we are going to develop the first step is develop the simple calculations over. Okay, so let us do some simple calculations. Now the pole pitch is equal to here, pole pitch or average pitch is equal to, so that is called YA is called Z plus 2 by P. Okay, so here what is the Z is given, the total number of conductors is the 34 plus 2 is given, so 36 by 4. So we are going to get the 9 as the pole pitch plus 2 minus 2. So 8 or 9 we are going to get the pole pitch or average pitch. Okay, so same this, so we are neglecting the even number, so we are taking the odd as a pole pitch. So this pole pitch or average pitch we taken as a back pitch and front pitch. So back pitch and front pitch must be odd or equal to pole pitch. So in this example I considering the pole pitch equal to the back pitch and front pitch. At the same time the back pitch and front pitch are equal values, not differ by the two values. Okay, so these are some calculations I have made here. So hence YB and YF is equal to 9. Yes, this is a first step simple calculations I completed here. Okay, for knowing the YB and YF I am going to calculated the simple calculations. First step is over. After knowing the YB, YF, second step is I am going to develop the table. Okay, so the table I am going to develop it. So how to develop the table? Let us see. Now develop one winding table. So winding table. So winding table we are going to develop. How we are going to develop? So based on the here I taken the back pitch is equal to 9 and front pitch also we taken the 9. So based on this one I am going to develop one table. Okay, so what is the table? Serial number, the back pitch, that is the YB is equal to 9 and front pitch. YF is equal to 9. Okay, so based on this table develop the complete all conductors. Okay, serial number 1. So now here I can represent this conductors 1, 2, 3, 4, 5. So just like it is going to the up to the 34 conductors. Okay, so that is for example this is a north pole, this is a south pole, and north pole and south pole. So these are all conductors under the influence of 4-pole machine. Okay, now here I can take this first conductor as an initial state. So I taken the first conductor initial state. Now this conductor has to connect one pole pitch. So what is the back pitch? 1 plus 9. I am going to connect the back now this one. So I am going to another one pole pitch. So this is same pole pitch, no. So I have to connect this with the other, so this is one side, so I am going to connect it here to the this side by here, this one pole pitch. So north pole, south pole. So where I am going to connect 1 plus what is the back pitch? 9. So then I am going to 10th. So I am going to connect this is a 10th conductor. I am going to connect it. Okay. So 10. After 10th conductor, so let us see. So I am going to connect the here 10th conductor. Represents that this is the 10th conductor. Let us assume. Now 10 plus here wave winding. We are going to the wave. So that is a 9 plus what is the front pitch? 9. So we are going to the 19th. Okay. So 19th conductor I have to connect it. So this is 10th conductor I am going to connect. Is for example, let us say this is the 19th conductor. Now this 19th conductor once again I am going to connect where? So another pole pitch. So that purpose you can take 2. Then so 19 plus what is the back pitch? Same 9. So that is equal, we are going to get it. So this is the how much? So 28th conductor. So you have to connect, for example, you are going to the 28th conductor. Now this 28th should be connected one pole pitch, another pole pitch. Where we are going to connect? So that purpose I am going to calculate 28 plus 9. Okay. So 28 plus 9 is equal to how much? That is equal to 37. But dear students, I have the limited only last conductor is a 34. Where is a 37 then? So here the 34 minus 37. So I am going to get its so third conductor. So 28 plus 9 is equal to 37. There is no 39 labeled conductor in my diagram. Hence the 34 minus 37, that is a 3. So I have to connect this going to and third conductor. I am going to enter here third conductor. So this connect. So this end I am going to connect third conductor. Once again third conductor has to connect where? So that purpose I am going to connect it here. Okay. So I am going to connect it. So third place. So the 3, whatever the value 3 plus 9. So what is the value? 12th conductor. You connect a 12th conductor here. Now after 12th you are going to connect where? So that is a 12 plus 9. Simple addition, all conductors. What is that one? That is the 21. Okay. So 12 here, the 12 plus 9 is a 21. So you know the 21 conductor, you connect the 21 conductor. After that 21 has to connect where? So I am going to connect 4th 21, okay, plus 9. What is their value? 30. Okay, 30. So we are going to connect it in 30. Where is the 30? Now 30 onwards we are going to connect where? So that purpose I am going to write it here, the 30 plus 9, 39, but there is no 39 labeled conductor in my diagram. So 34 minus 39, I am going to get it how much? So nearly the 5th conductor. So I have to connect 5th conductor. Is it 5th conductor? That means here we are going to enter the 5th conductor here. So now 5th, next it has to go to the which conductor? Simply write the all additions, dear students. So it is easy, but it is a tedious. Okay. So 5 plus 9. So I am going to get what is the value? This is called 14th conductor. Now 14 plus 9, I am going to 23 conductors. Okay. Next 6, 23 plus 9, what is the value? So 32 conductor. Okay. 23 plus 9 and 32 plus 9. So what is the value? 41. There is no 41. So I have to place which conductor? So 34 minus this one, 6 plus, so that is the 7th conductor. Okay, you can see 3, 5, 7, next is the odd numbers. You can remember that thing. Okay, so at the same time you have observed here is a 10, 12, 14, 16, it is going to increase. So a simple diagram, dear students, don't confuse it. Simply add it, fill up the table. 8th. Now what is the other one? 40, instead of 41 you can write the 7. 7th conductor, this is 7th conductor, plus 9 back pitch. So 16. Okay, 16 plus 9 is 25. Okay, next 25 plus 9, so 34. Yes, 34. So 34 plus 9, so what is the value? 43. Okay, so 43, there is no 43 conductor. So 34 minus 43, I am going to get it. So 9th conductor. Okay, so 10th. Now 9 plus 9, 18th. 18 plus 9, so 27. Okay, similarly you complete the total diagram till you are going to get is first conductor 1. Okay, so dear students, this is a simple diagram, simple addition. In lap winding, here is a plus, here is a minus, but in this case both are the plus value. But you have to keep in your mind that whenever the value reaches above our maximum number of conductors, you have to make it arrangement here. So this is a simple techniques. Okay, let us complete this total table. Okay, similarly you complete it. Let us see, that is one animation I created for you. Now you can see this the preparation of winding table based on the back pitch and front pitch. Now so first case, so 1 plus 9, that is a 10. Next the back pitch, so 10 plus 9, that is equal 10. Okay, so here the back pitch and front pitch, YB is equal to same. So now you can see what is the 9 plus 19 plus 9 is a 28, 28 plus 9 is a 37, 37 there is no 37, 34 minus 37 is the 3. Okay, now so same 3 plus 9 is a 12, and 12 plus 9 is a 21. Next 21 plus 9 is equal 30, and 30 plus 9 is equal 39, there is no 39, 34 minus 39 is equal 5, and 5 plus 9 is equal 14, and 14 plus 9 is equal 23, and 23 plus 9 is equal 32, and 32 plus 9 is equal 41, there is no 41, so 7. And 7 plus 9 is equal 16, and 16 plus 9 is equal 25, and 25 plus 9 is equal 34, 34 plus 9 is equal 43, so we can write it 9. Okay, so plus 9 plus 9 is equal to 18 conductor, and 18 should be connected to the plus 9, the front pitch, that is going to 27th conductor. Now 27 plus 9 is equal back pitch, we are going to the second conductor, and second conductor should be connected to the 9th front pitch, then we are going to get the 11th. So 11 plus 9 is a 20, 20 plus 9 is equal to 29, and 29 plus 9 is equal to 38, and that is equal, we can write the 4. The 4 plus 9 is equal to 13th. So 13 plus 9 is equal to 22, and 22 plus 9 is equal to 31. Okay, 31 plus 9 is equal to 40, there is no 40. So 34 minus 40 is equal to 6th conductor. Now 6 plus 9 is equal to 15th, and 15 plus 9 is equal to 24, and 24 plus 9 is equal to 33 conductor. So 33 plus 9 is equal to 42, so 42 can write 8, and 8 plus 9 is equal to 17th. 17 plus 9 is equal to 26, and 26 plus 9 is equal to 35. 35 is nothing but first conductor, where we started from the first conductor and ended the first conductor here also. Okay, here we can complete the first conductor. So that is the winding is completed. So it is going on, and completed to the first conductor. Okay, so this is the wave winding. So once you got it, this table, simply write the develop the table as usual, just like is the previous case. Only table preparation is the main important. After that you are going to simply, based on the table number, you just connect the front connections and back connections. Okay, so let us say that also. Now if possible, write the ring diagram. So what is the ring diagram? So indicates what are how the current is flowing in series, how it is connected. You can see here. So first, suppose I connected the conductor first one, that is connected to the 10th, from the 10th to 9, this table, only this is the top table. So then you can say 3 to connected to the here. So these are the similar how the conductors are connected side by side. so under the influence of the one pole pitch. So you can see the 34 is connected to the 23, so and 23 is connected to 32, 32 is connected to 7th, and 7th conductor is connected to 16th, and 16th connected to the 25th, and 25th is connected to the 34, and 34 is connected to the 18th, 18th is connected to the 27th, 27 is connected to the second conductor, and second conductor once again connected to the 11th, 11 is connected to the 20, and 20 is connected to the 29, 29 with 4, and 4 is connected to the 13, 13 is connected to 22, and 22 is connected to 31, 31 is connected to 6, 6 is connected to 15, and so here next is connected to the 24, and 24 is connected to the 33, 33 is connected to 8, 8 is connected to 17, 17 is connected to 26, and the 26 is lastly connected to the first conductor. So whatever the table top, so I have written in the form of the all conductors. I written the conductors 34. So these 34 conductors, how the current is passing through the one by way. So how the wave winding is going. This is a ring diagram. Okay. So here distance, no need to write the ring diagram here. For clarity purpose, how we are connected, this all conductors I shown for you. So last you are going to draw the ring diagram with brush positions also, that is required the fourth point. Okay. So these are the table and winding diagram. So I require the not ring diagram, I require the winding diagram. So in winding diagram, total complete figure is required. That is a total poles is required, total slots is required, total commutator segments is required, total brush positions is required, and total end connections and front connections is required. I am going to draw that one. Okay, let us see that is also. Now for development of simple wave winding, so what to do? Develop the winding diagram with help of the winding table. Just we design and connect end connections to the commutator segments, yes, and the place of brush positions based on the current directions in the conductors. So let us see, these are the conductors. Write the all conductors in parallel path, all conductors in some space. Okay, without any confusion, just you write the conductors. So whatever the conductors is given, just you write it. Okay, so that is the main things. Now after drawing these all conductors, so it is a double layer, So the top layers I represented the blue color, and bottom coil side they represent the red colors. Sometimes we can indicate it with a dash line. Okay. So now another step is label the all conductors. So odd numbers is the top and even numbers at the bottom. Okay. So represent this all. So how many conductors? 34 conductors. Now, so average pitch, the 8 poles average influenced by the north pole, south pole, north pole, south pole. Represent that also. You can see here. Dear students, you remember here the 34, only 38 conductors, 2 conductors here extra. So here you can observe here 17th, 18th conductors under influence of, suppose 17th conductor is under influence of the north pole and 18th conductors influence of south pole. You have to remember that thing. Okay. So these are the representation, just observe it. Okay. Simply draw the all conductors and parallel each other, and label it and represent the north pole, south pole, north pole, south pole for the current directions in the conductors to place the best positions. Okay. So this is a simple step as usual the lap winding. Then afterwards what to do? Let us do. So this all, let us assume in north pole influenced by the all conductors, the current carrying towards downward. In the south pole, opposite directions. Okay, these are the directions. This is the first step completed. Now I am going to connect the first conductor connected to here. You can see this first conductor is, I am going to connect the 10th conductor. Okay, this is the 10th conductor. The 10th is connected to the base of the table. So where I am going to 19th conductor. Where is the 19th? So this is the 19th conductor. The 19th conductor is connected to, where is the 19th? So this is the this is the 18th. So this is the 19th blue color. This is the next 19th connector is connected to the 28. So this is the, where is the 28? So this is 29. This is the 28th. Okay. So this is a one wave. So 1 is connected to 10th and 10th is connected to 19th and 19th connected to here 29th, no? So 29th, this one, and this 29th is connected to where? So the 28th, no? So 28th is connected to the third conductor. So it is going to third, there is no third conductor here. So this third conductor is here. So I am going to connect this entering third conductor. Now once again third conductor is connected here and third is connected to 12th conductor. So here we are going to connect the, where is the 12? 11, this is the 12. Okay. So this is the 12th conductor. You can see this is the 12th. Okay. 12th conductor is connected to where? So 12th should be connected to the 21. Where is the 21? So this is the blue is the 21. Okay. This is the 21. So this 21 connected to where? 21 connected to, just like you see the table. So 21 is connected to the 30. So where is the, this is the 29, blue is, this is the 30. Now, so 30 is connected to where? So you can see the table. So that is the 30 is connected to the, from the table. So 5th conductor. So here is a blue is the 5th connector. Okay, 5th. Now the 5th is connected to the where? So you are going to connect 5th, and the 5th is connected to the 14th. Where is the 14th? You can connect. The 5th is connected to the this 15th. Okay, 5th is connected to the 14th. Yeah. So this is the fourth. This one red color. Yeah. Okay. So this is connected to this. Similarly, the simple, dear students, simple based on the table, just follow, connect the end connection this side and connect the front connection this side. Complete the winding diagram. Okay. So there is an animation for you. You can see simple. Now, so based on the table, so you can see this table, keep in mind in table, and you know the connections are simple based on the one conductor, this two, this one, this two, this one, this two, this one, this, just you add it number of these conductors. Okay. So one is the, you can, here I showed here solid one is the top conductor in slots. So top one is a solid one and bottom one conductor is the dotted one. You can see. So top one is the blue and the bottom one is the red color, represent the dotted and indicated the even numbers. Okay. So similar way you connect based on the table. This is the another step. Okay. Now connect this one, all things. Let us do. So winding diagram. So you can, I am going to connect the first, I take in the first conductor, and what is the pole pitch? I have to connect the 10th conductor. So I connected the 10th conductor. Okay. From 10 to, I am going to connect it 19th. So you are going to 19th connector, top conductor, and next the other is connected to the other coil of the second coil. Other side of the other coil is connected to, so bottom of the slot. So that is connected to the 28, and the 28 end is connected to the, it should be connected to the which one? Third one. So third one you are going to get it. This is a third one. Okay. This ending is coming here. Now third one is connected and third one is connected to, so here the 12th is connected to the 21. Okay. So 21 is connected to the, say here 30. So 30 end is connected to the 5th one. It is coming to the 5th. So similarly, dear students, so I am going to connect this similar way. Just I am connecting the connections. Okay. So here just simply I am going to the wave. Represent. So now it is a, what is happened? The 27th conductor should be connected to the second conductor. So where is the second conductor? So here this is a second conductor. So I have to enter here. So we are going to this one, second conductor. So I placed the, this is a second conductor. Okay. So it has to come current this direction. Now second conductor. Okay. The second conductor is connected to the normally to the same complete this one. After that it is going to the fourth conductor. Now fourth entering and it is going to the another conductor, sixth entering is completed the one wave, 8th conductor. Okay, so 8th is completed and is going to the completed. Now this is the total winding diagram, dear students. Completed all conductors as per the table diagram. Okay, so this is a total winding diagram only part. Okay, so how? So based on the table, connected end connections and front connections. Label the all conductors. You can see it. So similarly, you have the drafter. You can write it very clearly. Okay, so I have prepared this manually, but it is very difficult to prepare in the software. So you have the drafter. You can easily write. Okay, so this is a one complete winding diagram end connections. Now I am going to connect these end connections. Where these end connections? Here you can see. So these all end connections I am going to connect my commutator segments. Okay, this commutator segments, that is the second part. After completion of this thing, this is the first part and this is the second part. Third part, I am going to place the brush positions based on the these current directions. This is the current directions. What are the current directions? Okay, so let us see. Now this is a one diagram. After that, this is a double layer wave winding, dear students. This is a wave winding. Okay, so you have to complete this similar way. Okay, neatly with patiently. Now, so I completed this diagram. So what to do? So I am going to connect this winding is nothing but this winding. Now this commutator segments should be connected here. I am going to connect these commutator segments. So this is the commutator, nothing but whatever the winding here connecting the wave or lap to the segments, how the segments are connected. So now we are going to connect this one. This is the commutator on which I am going to place the brushes. So I am going to place the brush here. Okay, so the brush also I am going to place it. You can see here. So the brush positions also you can see. This brush positions. Now the second step, I am going to connect the commutator. After that, I am finishing with the brush position, positive and negative. Okay, let us do. Now these are the all commutator segments. So 17 commutator segments. Each commutator consists of two coil sides. Okay, top one and bottom one. Now connect the end connections. So I connected the here all towards the front, connected to the all my commutator segments with copper wires. Okay, now so based on the current directions, I am going to place where I have to place the brushes. As we know that in any commutator connected to the two ends of the coils, the current is coming towards the commutator segment represented as a positive, and the coil in which the current is going away from the commutator segment represented as a negative, as usual. Okay, so let us see. Now here the conductor, so second conductor, you can observe it, the conductor 9th is current going away. At the same time, here the conductor 36 is connected here, you can see. So that is a nearly 34 conductor also going to away. So both are connected the segment, commutator segment 2. So that's why away from the commutator segment I represent as a blue color. Similarly, in the 11th commutator segment, the end connections of 26th coil side and 18th coil. So the current is going away from the 11th segment. So represented as a blue color. So blue color represented as a negative coil, negative brush. Okay. Similarly, next red one. Now the segment, commutator segment 6, you can observe it. The current in the coil of 8th conductor is coming towards the down. At the same time, the current in the, you can see here 8 that is what is done near 17th conductor. The current is coming towards the 6th commutator segment. Both current is coming towards the 6th segment. We taken as a positive. Similarly, in the 15th also you can observe here, dear student, from the it is coming to the what is the one? 26th conductor, and another is the coming from the first conductor, current coming towards the first conductor, that is connected to the 15th slot. So red indicated the positive terminals and blue indicates the negative as per my assumption only. Okay, so now we connect it all positive terminals and negative terminals parallel each other. Now this is a negative and this is connected to the positive. So this is the total winding diagram, dear students. This is aim to draw your aim. To complete these settings, so you have to follow the simple calculations, you have to prepare the table diagram, and based on the table diagram you are going to connect the end connections. After that you have to place the commutator segments connections, and then you are going to place the brush positions. This complete winding diagram. Okay, so it will take the time, but you have to practice it, dear students. Now after completion of this one, simply write the ring diagram. Okay, so this is a complete the armature. So this total winding inside here, the commutator segments. So you can see this is the commutator segments, this is the total winding here, and the commutator segments here. Okay, so brushes placed here. So these are the total winding diagram, given winding. Okay, then the ring diagram, simple ring diagram, just what are the conductors connected. So simply where the current direction is going from the commutator segments, so we take the negative and that is a positive. So the total winding of wave diagram. Dear students, this is a one simple problem. So what we have seen, we developed a double layer wave winding with given data. Okay, we completed. So don't confuse, dear students, you have to follow step by step. Okay, so these are the total winding diagram, dear students. Please practice it. Thank you for listening my class.